all possible distances between any 2 points of the set. And some of the properties I'm going to discuss. Whenever E subset of X, diameter of E is same as
Your voice is not clear and the background disturbances. Please.
E equals to diameter of E closure. Diameter of E equals to diameter of E closure. This is very, very important property. Why? Because if you take an example, you start with X with respect to usual metric, X equals to R with respect to usual metric, right? You take E equals to open 0, 1, right? What is the closure of the set? Closure of the set is close 0, 1. So therefore, what is the diameter of E? Diameter of E is nothing but actually difference between these 2 points. That means 1. Similarly, diameter of E closure is nothing but 1. Similarly, difference between these 2 points, 1. So diameter of E equals to diameter of E closure. We can easily prove by supremum property. One can easily prove by supremum of the set. One can easily prove it by supremum of the set. Right? Next property is property number 2. Suppose your metric space is X. Suppose A comma B are subsets of X. Right? So diameter of A always less than or equals to diameter of B. Right? One can easily prove it by using supremum property. Right? For example, you start with X is equals to R with respect to usual metric. X is equals to R with respect to usual metric. You can take, for example, A equals to open 0, 1. Take B equals to suppose minus 1, 3. Right? So automatically, clearly, easily one can easily observe that A is subset B. What is the diameter of A? Diameter of A is the difference between length of the interval, that is 1. What is diameter of B? Diameter of B is nothing but 4. So clearly one can easily observe that this diameter of A less than diameter of B. This is also very, very important property. Is it clear? Right? Next is, suppose you can have A and B which are non-empty subsets of X. Yesterday we have shown this result. We have argued this result. So diameter of A and B always less than or equals to diameter of A plus diameter of B. Right? So these are the properties of diameter of A and diameter of a set. Next definition is distance of a point to the set. Distance of a point to a set. So this is very, very important for CSIR, right? At least one question will occur according to the definition, right? This is my metric space. You take any set E, any point you take in a metric space. Look at all possible distances. Right? So look at the supremum or infimum of all possible distances of the point to the members of the set E. That means you start with any subset of X. So you take any point which in a metric space. Distance of a point X to E is denoted by like this. Distance of a point X to E is denoted by like this, which are defined by infimum of all possible distances of X to all points of the set E. This is my definition. Distance, the infimum of all possible distances of a point to the all possible points of the set E. Right? Suppose my first condition, if you take E is an empty, automatically this set is empty. This set is empty. So if you take the infimum, what is infimum? What is the infimum of empty? Anybody? What is the infimum of empty?
Minus infinity.
No, infinity.
Oh,
Infimum of empty is infinity. Right? That means if you take E is an empty, automatically distance between any point to empty set is always infinity. This is by convention. We can assume that. Right? So laws of generality, for convenience, we start with non-empty sets. Suppose, let us start with an example. X with respect to usual metric. X equals to R with respect to usual metric. Right? Suppose my set is closed interval 0, 1. Closed interval 0, 1. So what is my, so suppose this is my interval. This is my set actually. This is my metric space. This is my interval. Right? Suppose your point is here. Your point. What is my point actually? X equals to 2. What is my point? X equals to 2. So what is my question is, what is the distance between 2 to the set E? So what is my definition? Infimum of all possible distances of 2 to all points of the set E. Right? Anybody? What is, yeah, 1, because this is the least distance, this is shortest distance, this is a minimum distance. So what is this? What is this? 2 minus 1, that is what? 1. Is it clear? Is it clear? So this is what actually minimum distance. You can easily prove it by the infimum property. So the distance is what actually 2 minus 1. Therefore, it automatically 1. Suppose your point is actually 1.1 by 2. What is the distance between 1 by 2 the set E? Anybody? That means your set is like this. Close 0, 1. Your point is this. What is my distance between point to the set E? Anybody?
0.
0, because it's a point of the set. It is a point of the set. How? How? If you take any point in a set, automatically the distance between x to e is 0. Why? Distance is always non-negative. So this is always non-negative. So this is always less than or equal to. What is this actually? Infimum of all possible distances from x to y such that y belongs to e. Right? So infimum is always lower bound for the set. Therefore, this is always less than or equal to d of x comma y for every y. That means distance between x to e always less than or equal to d of x comma y. This is true for every y. In particular, I can take y equals to x because x is in e. X is in e. In particular, distance between x to e should be less than or equal to distance between x comma x. Distance between x comma x is 0 because whenever the points are coincident, the distance is 0. Therefore, distance between x to e is less than or equal to 0. That means what? Distance between x to e is 0. So what you observe? What you observe is that when you take any point within a set, the distance always 0. Is it clear? This is very, very fundamental result. Right? Is the converse true? Is the converse true? What about the converse? If the distance is 0, distance between x to the set is 0, does it mean that x belongs to E? The answer to answer this question need not be in general. Suppose you can take x equals to R with respect to visual metric. Right? Visual metric. My set is actually open 0, 1. My set is what actually? Open 0, 1. So what is mean by, so my point is actually what? 0. X equals to 0. Clearly x is equals to 0 does not belong to set E because my set is open 0, 1. Therefore, 0 does not belongs to E. Therefore, what is meant by distance between x to E? That means distance between 0 to open interval 0 to 1. Anybody? What do you mean by distance between 0 to this set? Anybody? What is meant by distance between 0 to the set itself? Anybody? What is this? 0. Why? Because you take any point in the set, that means what? Automatically, that means x belongs to open 0, 1. That means what? X is always distance between this to this, is nothing but what? Is always is equals to x because x is positive. Because x is right side to 0, x is positive. Therefore, this is always positive. That means what? X is 0 less than mod x minus 0. This is true for every x belongs to E. That means 0 is lower bound for the set, this set over E. That means what? 0 is a lower bound means what? Infimum of this set over E is the greatest lower bound. Right? Because infimum of the set is always greatest lower bound. Therefore, this is bigger than or equal to 0. Therefore, what is this? This is distance between 0 to set E. That means 0 less than or equals to this. 0 less than or equals to distance between 0 to E. Is it clear? Because 0 is a lower bound, for this set. Therefore, infimum of the set is actually particular set over E is the greatest lower bound. Greatest lower bound is always greater than or equals to any lower bound. But this greatest lower bound is nothing but distance between 0 to E. Therefore, distance between 0 to E is always bigger than or equals to 0. Yes or no? Is it clear? But the thing is, distance is nothing but actually infimum of the set. Infimum of 0 to any point on the set X or E, but infimum is always lower bound for the set. Therefore, this is true for every X belongs to E. This is true for every X belongs to E means what? In particular, I can take 1 by 2 n's. For E, 1 by 2 n belongs to E for every n belongs to n. Yes or no? If you take n equals to 1, 1 by 2 belongs to E. If you take n equals to 2, 1 by 4 belongs to E. Right? Therefore, in particular, distance between 0 to E always less than or equals to 0 minus 1 by 2n. This is true for every n. Yes or no? Because I can take x is equals to 1 by 2n. Right? Now, this is true for every n means what? Letting n tends to infinity, this is always less than or equals to, by sandwich theorem, is always less than or equals to, this tends to 0. Right? So, therefore, distance between x to E equals to 0. Therefore, distance between 0 to E is 0. Distance between 0 to E is 0, whereas my point should not be in the set. Right? So, converse of this may not hold, may not be true. Is it clear? Is it clear?
Yes, sir.
Yes. Right? Suppose you can take, see, ఇది 2011 CSIR లో వచ్చిన క్వశ్చన్ ఇది యాక్చువల్గా. If you take any metric space, any substitute take distance between x to E to answer this question. Actually, this in general false above statement, but distance is 0 if and only if x belongs to E closure. Closure of the direct statement వచ్చిందండి 2011 CSIR పేపర్ చూడండి, డైరెక్ట్ ఉంటుంది మీకు. సో distance between x to E 0 if and only if x belongs to E closure. That is if and only if, in particular, distance is 0 if and only if, that means distance is 0 between x to E is 0 if and only if x belongs to E, if whenever E is closed, E closure is equals to E. That means E is closed set in x. Is it clear? Distance between x to E is 0 if these are direct statements. One can easily prove it by using limit point definition. One can easily proving by limit point definition and closure of the set. Easily prove it. So distance between x to E is 0 if and only if. Generally, what you have seen actually, distance between x to E is 0. That need not imply that x belongs to E. Right? This result may fail. But the thing is, distance is 0 if and only if the point should not be in E, but the point should be in the closure of E. That is what important. Is it clear? Is it clear? Or else, we can rewrite the statement as like this. Set of all points in X, E closure can be written as, because X is in enclosure means the distance between X to E is 0. So we can write this statement as E closure is nothing but set of all points in a metric space in such a way that distance between X to E is 0. These also equivalent statements. Is it clear? 1, 2, 3. These 3 statements are very, very important. Right? The set of all points in a metric space in such a way that the distance between X to E is 0. Is it clear? So this is also equivalent statement, right? Suppose one can use it. Suppose you can take an example. Suppose x is equals to r with respect to geometry, right? My set is, for example, rational numbers. My point is actually 2. What is meant by distance between 2 comma q? Anybody? You know, actually, what is 2? Actually, 2 is a rational number. So 2 belongs to q. Yes or no? 2 belongs to q. Already told you, whenever 2 belongs to q, distance between 2 to q is always 0. Right? So what is the distance between root 2 comma q? Anybody? Right? It is also 0. Why? Because root 2 is a limit point of the q. Right? But limit point is always contained in the closure of q. Yes or no? Therefore, because closure is nothing but what? Q in its derived set. Therefore, limit points always contained in the closure of the set. Therefore, root 2 belongs to closure of the set. Therefore, whenever root 2 belongs to closure of the set, the distance is 0. Is it clear? You know, root 2 belongs to the closure of set because root 2 is a limit point of a q. So once root 2 belongs to q, root 2 belongs to limit point of q, automatically root 2 belongs to the closure of the set. Therefore, the distance between root 2 comma q is 0. Is it clear? Is it clear?
Yes, sir.
Yeah. Right? Suppose you can take this. Suppose x is equals to r with respect to discrete metric, right? X equals to y. My set is for example, close 0, 1. What I mean by distance, suppose I can take x equals to 2, amma. Suppose I can take x equals to 2. What does it mean by distance between x to e with respect to this metric, discrete metric? Anybody? So you know that actually this is my set actually. Go through the geometry. So this is my 2 actually here. So any point you take in the set. What is my definition of distance between x to e? Definition means infimum of all possible distances of a point x to all possible distances of all points of the set e to x. Set e to x. That means you take any point with in the set. Are they equal? Are they equal? No, right? Because x is in the set and x is in the set, but 2 does not belong to there. Therefore, x cannot be 2. X cannot be 2. So for any point you take in x in E, x should not be equals to 2. That means what? Whenever x should not equals to 2 in discrete metric, what is the distance? 1. Is it clear? What is the distance? 1. That means it is true for every x belongs to E. Yes or no? Any point you consider, the point x and 2 are not equal. So in discrete metric, when the points are not equal, your distance is 1. So your distance between x to 2 is a constant function. That means what? Distance between x comma 2 is nothing but what? Is nothing but what? Or x belongs to E. Nothing but what? Infimum of what is this distance? 1. Whenever x belongs to E. So infimum of 1 is nothing but 1. But what is this? Distance between 2 to E with respect to discrete metric. Is it clear? Is it clear?
Okay, sir.
Okay. Suppose you can take this. X is equals to R with respect to usual metric, right? My set is nothing but actually irrationals, right? My set is nothing but irrational. Suppose I can take x is equals to 2. What is mean by distance between irrationals? What is mean by distance between irrationals? Distance between 2 irrationals? Anybody? What do you mean by distance between 2 irrationals? Anybody?
0.
0, right? Because 2 is a limit point. You take in a neighborhood, it contains at least one irrational. Therefore, 2 is a limit point of the irrationals. Therefore, 2 belongs to closure of the set. 2 belongs to the closure of the set. Therefore, distance is 0, right? Suppose you can take in R2 with respect to D2 metric, right? In D2 metric, suppose x1 minus y1 whole square plus x2 minus y2 whole square, right? Right? So my set is suppose x-axis, right? Suppose my point is a equals to suppose 1 comma 2. This is my set. Actually, my set is x-axis. My point is actually 1 2. Anybody? What is mean by distance between a point? You can take A. Distance between A to set E. Anybody? What is this? What is this?
2.
Huh? Hello. What is this?
2 is
2, right? Because you know that in geometry, any perpendicular distance is the shortest distance, right? Any perpendicular, a point which is not on the line. What is the shortest distance? The shortest distance is nothing but a perpendicular distance drawn from the point to the line, right? This is my perpendicular distance. So what is the perpendicular distance? 2. Is it clear? What is my
Yes, sir.
perpendicular distance? 2. Is it clear? So some more properties. These properties are very important. You take any metric space, any subset of metric space, distance between x to E is nothing but distance between x to closure of the set. X to closure of the set. For example, this is an important property. For example, you start with the usual metric or with respect to usual metric. Suppose you can take same little bit of example, open 0, 1. What is the closure of the set? Closure of the closed interval 0 to 1. So therefore, what is mean by distance between, suppose you can take 2 to E. right? What do you mean by distance between 2 to E? Is nothing but 1, right? Difference between this to this. That means what? 1. What do you mean by distance between 2 to E closure? 2 to E closure means this is nothing but distance between this to this. That means what? 1. So that means distance between X to E is same as saying that distance between X to E closure. Is it clear? Right? Next is very important property is whenever E is subset of metric space, distance between X to E minus distance between Y to E is less than or equals to distance between X to Y. For every X, Y belongs to X. Distance between X to E minus distance between Y to E modulus is always less than or equals to distance between X to Y. So using this, you can easily conclude that it is uniformly continuous function. This function from any metric space to real numbers, this function is uniformly continuous. We can go through the right uniformly continuous. And because you give me any epsilon, I can find the delta is same. You give me any epsilon you take. What is my delta? My function is nothing but what? F of X is equals to distance between X comma E. Yes or no? My function is distance between X to E, right? You give me any epsilon, my delta is actually what? Epsilon. So it is independent of this. So therefore, F of X comma minus F of Y is nothing but what? Your F of X is nothing but distance between X to E. Your F of Y is nothing but distance between Y comma E. You know, by this inequality, by this standard inequality, very standard inequality, by this standard inequality, this is always less than or equals to distance between X comma Y. But this is less than delta if, you know, whenever this is less than delta. But I'm choosing delta is nothing but epsilon, right? Therefore, distance between the images is very closer to each other whenever the distance between the points of the domain are very closer to each other. Therefore, it is uniformly continuous. So this inequality is very, very important. Is it clear?
This is any metric space, sir. This is true in any metric space, sir.
Yeah, this is true for any metric space. This is
Yeah.
true for any metric space.
Above also true for any metric space, sir. Above result.
This one.
Above.
Above this one. Closure.
Yeah. Sir.
Yeah, this is true for anyone.
Any metric space.
Any metric space.
Thank you.
Okay. Right. So using this property, that is nothing but it's uniform continuous. F of X is equals to distance between X to E is always uniformly continuous function. Uniformly continuous function. It's a real world function. Uniform continuous function. Right. Next definition. Distance between. So we have seen distance between any point to the set. Now I like to generalize distance between 2 points. Distance between two sets. Sorry. Distance between sets. So let us start with any two subsets of a metric space, right? So distance between A to B is nothing but infimum of all possible distances of any 2 points of the corresponding sets. This makes sense, you know, actually this makes sense because actually any distance between any 2 points is always non-negative. Yes or no? It makes sense. This infimum exists or not, you need to check it. Infimum for the set need not exist. You already know that. But you know that this 0 is a lower bound for the set. Yes or no? For the set A belongs to A, B belongs to A. For this set, 0 is a lower bound. Once 0 is a lower bound, it's a non-empty set. So automatically, any set which has a lower bound has an infimum by completeness property. Therefore, it makes sense. It makes sense. Is it clear? This definition is meaningful. It is well-defined. It is well-defined definition, right? Again, same argument. If either at least A empty or B empty, what happens? My this set is empty. My this set is empty set. Yes or no? This is empty. So what is the infimum of the set? Infimum of the set is infinity. Therefore, distance between A to B is empty. Infinity. So at least one of them is empty. At least one of the set is empty. Our distance between two sets is infinity. Is it clear? Is it clear? Anybody? We can take an example. Suppose R with x is equals to R with respect to usual metric. Mod of x minus y. Right? My set is A is equals to open 0, 1. My set B equals to Suppose you can take 2, 2, 3. What do I mean by distance between A to B? What is my definition? I already told you. Infimum of all possible distances. Infimum of all possible distances of the corresponding points of the set, right? So what is the minimum distance? You know, what is the least distance? You know, this means this is a point, this is a point. So therefore, what is the least distance? It's nothing but what? 2 minus 1, that is nothing but what? 1. So you can prove this idea by lower bound property, as already told you, this technique. Using this technique, easily one can easily compute that. One can easily compute using this technique, using this technique. Okay, any problem can be found directly, mathematically, analytically by using this technique. But I don't want to show you for every problem because time waste. So that means, so what is my distance between A to B? Means, you know, look at the points. Look at the points. Points of the set end is my A set is ended with E1. My B set is ended with left hand point is 2. Therefore, they are closer to each other. Therefore, the distance between 1 to 2 is nothing but 2 minus 1. That is nothing but 1. Is it clear? Suppose you are in usual metric. Suppose you are in discrete metric. Suppose same thing. Suppose you are in discrete. Suppose you're in discrete. My sets are same. My sets are same. What do you mean by distance between A to B? Anybody? What do you mean by distance between A to B? Anybody? You know, you take any point here, any point in a set A, you take any point in a set AB. So A and B are not equal. A and B are not equal. Once A and B are not equal, distance between A to B is 1. In discrete. In discrete, distance between A to B is 1. So this is true for every AB. That means this is true for every AB. That means infimum of this set, this is nothing but singleton. So infimum of is nothing but singleton. Infimum of 1 is nothing but 1. Therefore, distance between A to B is 1. Is it clear? Because you know what is this infimum? Infimum of A to A comma B such that A or A, B or B is nothing but infimum of this set is nothing but singleton. Therefore 1. Is it clear? Is it clear? Hello?
Okay.
So next to property is, you take any subset of a metric space, you take any B is any subset of a metric space, right? Distance between A to B, what is this distance between A to B? It's nothing but infimum of all possible distances between A to B, such that A belongs to A, B belongs to B. Therefore, you know, it is a lower bound for the set. You know, it is the greatest lower bound. Therefore, always less than or equal to distance between A to B. This is true for every A belongs to A, B belongs to B. That means distance between A to B is always less than or equal to distance between A comma B for every A belongs to A, B belongs to A. Using by lower bound property. Is it clear? Right, by lower bound property, right? Next is, suppose you can take any non-empty sets, any intersecting set, means they are not disjoint. Suppose you take two sets which are not disjoint, which are subsets of metric space, not disjoint. That means they may intersect at some point. Your distance between A to B must be 0, right? Because actually, what is meant by distance between A to B? Distance between A to B always less than or equal to, by using this property. This is true for every A, every B. Yes or no? But this intersection contains at least one point, because intersection is non-empty. Therefore, it contains at least one point. That means X is in A as well as X in B. This is true for every A, every B. Therefore, in particular, this distance between A to B is always less than or equal to X comma X. But distance between X comma X is 0. And distance is always non-negative. Therefore, A less than or equal to B, B less than or equal to A. Therefore, distance between A to B is 0. If A intersection B is non-empty. Is it clear? Is it clear? Yes. But what about this converse? If A intersection B is non-empty, your distance between A to B is 0. What about the converse? What about the converse? Anybody? What about the converse? So converse may not be true. For example, you start with actually X is equal to R with respect to usual metric, right? Mod of X minus Y. Suppose my set is rational numbers. right? My set is rational numbers, B A equals to, my another set is irrationals. Look at the geometry, Q is dense in R, of course R minus Q also dense in R. So all points of A are closer to the all points of B because Q is dense in R, Q is dense in R, right? R minus Q also dense in R. So therefore the points in A are very closer to the points in B. Yes or no? So by using this geometry, we can expect that the distance between A to B is 0. But how can you prove it? The basic idea is distance between A to B is nothing but infimum of distance between A to B, where A over A, B over B, right? But distance is always a lower bound, therefore is always less than or equals to a distance between A to B for every A belongs to B, B belongs to B. So therefore, this in particular, distance between A to B always less than or equals to distance between, I can take A equals to suppose 2 by n, because 2 by n is a rational number, no doubt, for every n, right? I can take B equals to root 2 by n. Yes or no? Root 2 by n is always irrational. It is always irrational, right? This is true for every n. But what is my distance between these 2 points? Modulus of 2 by n root 2 by n. By triangle inequality, this is 2 by n plus root 2 by n, right? Therefore, what is this? This is true for every n. This is true for every n. That means letting n tends to infinity, always by sandwich theorem, is less than or equal to 0, because 2 by n tends to 0, root 2 by n tends to 0, therefore this 0. That means distance between A to B is 0. So what you observe? Your A is my A set is rationals, my B set is irrationals. They are disjoint, they're disjoint. Clearly they are disjoint, but whose distance between A to B is 0. Is it clear? This is very, very important property, right? Or you can take this one also. You can take this one also. Suppose you can take A equals to R with respect to usual. My set A is natural numbers, counting numbers, right? My set B is nothing but, suppose you can take like this, n plus 1 by n, such that n over n, right? So thing is, actually you go for this. This is 1. This is my first set. What is my second set? 1 plus 1 means 2. So some point coincident, is or no? 1 plus 1. What is my first point of the set? 1 plus 1, 2. So we can expect that distance between A to B is 0. We can expect that distance between A to B is 0. But how to prove it? That distance between A to B always less than or equals to distance between, this n, because any natural number you take, and n plus 1 by n. So n plus 1 by n is also element of this. This is true for every n. But here in the usual metric, this is always modulus of n plus 1 by n for every n. That means this is nothing but 1 by n, right? So distance between A to B is always less than or equals to 1 by n. So again, by sandwich theorem, this tends to 0. Therefore, distance between A comma B is 0. Is it clear? Is it clear? So the distance between A to B is 0. Suppose you can take in R2, these are the standard examples. In R2, suppose you can take my A set is rectangular hyperbola, set of all order pairs in such a way that xy is equals to 1. My B set is actually what? My B set is, suppose you can take axis. That means xy equals to 0. So my rectangular hyperbola is nothing but, xy equals to 1 means what? Both are positive. It is sitting inside in the first quadrant as well as the third quadrant, because xy is equals to 1, 1 is positive. Therefore, it is in the first quadrant as well as the third quadrant. My B set is nothing but axis. My B set is nothing but what? Axis. You may observe that somewhere it is closer to this, but it doesn't touch x-axis. Somewhere it is closer to x. So we may observe that distance between A to B is 0, but A intersection B is 0. A intersection B is empty. Why? Because clearly A intersection B is non-empty, empty set, because both are disjoint. So distance between A to B always, this is always less than or equals to distance between A to B for every A comma B, A belongs to A, as well as for every B belongs to B, right? This is true for every A. In particular, I can take distance between, suppose I can take n comma 1 by n. This is my point. So n comma 1 by n is in my A set. Why? because actually n into 1 by n is 1. Therefore, this is my point in A set. What is my point in B? You can take n comma 0. This is in B, right? So n comma 0, which is in B. This is true for every n. But what is meant by distance between A to B? Formula under root of, this is my D2 metric. Yes or no? So therefore, what is meant by distance between A to B? Euclidean metric, n minus n whole square plus 1 by n whole square, 1 by n minus 0 whole square. That is nothing but 1 by n. That means distance between A to B always less than or equals to 1 by n is non-negative. This is true for everything by sandwich theorem. Distance to 0, distance to 0. Therefore, middle piece is always less than or equals to 0. That means equals to 0. Distance cannot be 0, cannot be never be negative. Therefore, distance is 0. So both are disjoint. Both are disjoint, but distance is 0. Right? Distance between the two sets is 0. Yes or no? Is it clear? Right? Right? These are the standard examples, right? Again, we can have some important properties. Distance between A to B, whenever A comma B are the subsets of a metric space, any two subsets of metric space, for the sake of our convenience, A should be non-empty, B should be non-empty. Distance between A to B is nothing but distance between A closure and B closure, and distance between A closure comma B, and distance between A comma B closure. One can easily prove by using infimum property, infimum of the set property, and closure of the set property. Easily prove it. One can easily prove it. For example, suppose you can take x is equals to r with respect to means closure చేసిన మామూలుగా చేసిన distance with the difference ఏమి ఉండదు. But that is what actually meaning of the statement. Right? Suppose my set is A equals to open 0, 1. Suppose my B set is, suppose you can take 2 to 3. Distance between A to B already we have seen 1. Distance between A to B is 1. Similarly, distance between A closure, B closure. What is this? My A closure is actually close 0, 1. My B closure is nothing but 1, close to 3. Right? So distance between close 0, 1 to close to 3 means what? 1. So therefore, distance between A comma B are nothing but distance between A closure comma B closure. Is it clear? Is it clear? Hello?
Okay.
Yes. Now, my definition is convergence of a sequence. Means, in fact, sequence, first of all, sequence in a metric space. Right? Sequence in a metric space. What does mean by sequence in a real numbers? Sequence in a real numbers. What do you mean by sequence in a real numbers? Sequence is nothing but a function from natural numbers to real numbers. Any function that you take from natural numbers to real numbers. This is my sequence. Any function that you take from n to r is nothing but real sequence. Similarly, one can extend this idea to any metric space. So you take any metric space you take. This is my natural number. Suppose you assume that this is my natural number. Any function from x to n, n to x is nothing but a sequence in a metric space. Any function that you take from natural numbers to a metric space. Right? So this is nothing but my nth term of the sequence. My sequence is generally denoted by these are my nth terms, means first term is 1, second term is 2, third term is 3, going on. This is my sequence. Right? Is it clear? Right? So when you have a sequence, again natural question arises. What is my natural question? So when do you say that sequence converges? So when do you say that? There are two possibilities actually. In fact, whenever you are given a sequence, it may convergent or divergent in metric space. But in real numbers, we can have a oscillate finitely, oscillate infinitely, diverges to infinity, right? Something else, right? But we are working in an arbitrary metric space. But we don't have an order. Understand? In C, there is no order. Understand? So there are two possibilities only: divergence and convergence. Because actually, what you are working in a arbitrary metric space. In general, there is no order because it's not a partial order. Suppose you can take C, it's not a partial order. With respect to usual order, we cannot compare two complex numbers in general. Yes or no? So therefore, so that what you observe. So generally we can deal with convergent and divergent sequence. So what do you mean by convergent sequence? What is the definition? Whenever you start with a metric space, suppose you take any sequence in X. So we say that Xn is convergent. We say that Xn is convergent in X if and only if there exists at least one point in a metric space in such a way that for any neighborhood you take, any neighborhood around this, any neighbor, small neighborhood or big neighborhood, it contains all terms of the sequence. Except finitely many leave. We don't know whether it leaves or not. It may, of course, some of the sequence converges to some point means what? It may contains all terms of the sequence also. For example, constant sequence. But except finitely many, we don't know. But all the terms should be sitting inside the ball center x comma with radius epsilon for every epsilon. That means for each neighborhood, any neighborhood of x, there exists at least one stage in such a way that the distance between x to xn to x should be less than epsilon for every after the stage h, after the finite stage h. That means this is equivalent to say that xn comma x, distance between xn to x is less than epsilon means what? This xn belongs to the ball center at x comma epsilon after the stage. This is true for epsilon. That means what? What does it mean by this? Every neighborhood, what do I mean by this? For every neighborhood you take, it contains all terms except finitely many. After h terms of the sequence, all terms should be sitting inside the ball center x comma epsilon radius. That means every neighborhood of x contains all terms of the sequence except finitely many. Right? By using the definition. Is it clear? Is it clear the definition? See, go back to the definition. Is it clear? Anybody? Hello?
Not specific. 1 second, sir.
Alakari చెప్పండి sir.
So xn converges when do you say that xn converges? Means if there exists at least one point, this is my metric space. There exists at least one point, of course, that point must be unique. I will show that later. So there exists a point. You take any neighborhood, you take, it contains all points. It contains all terms of the sequence. ఈ sequence లోని అన్ని terms ఇందులోనే ఉండాలి. Except finitely many. Suppose A, B, C, suppose D, suppose D100, suppose D2000. Finitely many outside ఉన్నా పర్వాలేదు కానీ అన్ని మాత్రం ఇందులోనే ఉండాలి. That's what definition of a sequence convergence. We say that xn converges to x. In this case, we say that xn converges to x. Xn converges to x as n tends to infinity. Or we denoted it by limit n tends to infinity, xn is equals to x. Or in this argument, we say that x is the limit of a sequence. Is it clear? Is the definition clear? Any neighbor you take, it contains all terms of the sequence except if finitely many. Suppose you can take this. Right? Suppose my sequence is xn is equals to, suppose 1 by n, r with respect to usual metric. X is equals to r usual metric. For understanding purpose, you can have a lot of examples. The thing is, actually, you know that in usual metrics, in basic analysis, we know that actually the sequence 1 by 2, 1 by 3, this tends to 0. Because it is decreasing sequence too, we may guess that 0 is a limit. We may guess that is a guess limit of a sequence xn. But how to show this? It's a 0 is a limit of a sequence means you start with any neighborhood. What is my neighborhood? 0 minus epsilon, 0 plus epsilon. Yes or no? You start with any neighborhood, any epsilon you take. I want to show that this neighborhood contains all terms of the sequence. I want to show that This neighborhood contains all terms of the sequence. Yes or no? Is it clear? So therefore, I want to show that the distance is less than epsilon. See, this distance is less than epsilon if and only if this 1 by n is less than epsilon. That means this n is bigger than 1 by epsilon. So I can choose my capital N is nothing but step of this plus 1. If I choose this stage, after all stage, the terms distance between n to 0, 1 by n to 0 should be less than epsilon. Right? This is my stage. After this stage, if I set this stage n is equal to this, that means distance between xn to 0, it should be less than epsilon after the n bigger than equals to n. That means what? Xn converges to 0 in usual method. Is it clear?
Sir,
If
ఇక్కడ capital N 1 by epsilon తీసుకుంటే ప్రాబ్లం
1 by epsilon step function.
అలా కాకుండా
Step function.
1 by epsilon తీసుకుంటే
1 by epsilon తీసుకుంటే ఇంటీజర్ రాస్తారు. సపోజ్ ఇక్కడ టేక్ epsilon is equals to 0.1 తీసుకున్నారు. 1 by epsilon తీసుకున్నారు అనుకోండి, ఇక్కడ ఇది స్టెప్ ఎక్కడ వస్తుంది సార్? సపోజ్ నేను epsilon equals to 2 ఇచ్చాను.
అంటే n ఇక్కడ n అనేది నేచురల్ నెంబర్ సార్ ఇంటిజర్.
You find a natural number. And you find a natural number. There exists n, and h belongs to n. H is my natural number. H is my natural number. The stage is my natural number. Okay, is it clear, sir? Suppose if I take epsilon equals to 2, what is my 1 by epsilon? It's nothing but 1 by 2. That means 0.2. So definitely you can use step function. Is it clear, sir? Is it clear, sir?
వాయిస్ రావట్లేదు సార్.
వాయిస్ ఇప్పుడు వినిపిస్తుందా సార్? హలో.
But in Roche textbook you mentioned for there exists a number n, sir.
Yeah, there exists.
Can it a Roche? A sequence
Hello?
Sn converges to a real number L. If for each epsilon greater than 0, there exists a number capital N. He not mentioned that n is natural number.
ఇక్కడ నేను h అని మెన్షన్ చేశాను నోటేషన్ లో. యాక్చువల్ గా నేను n తీసుకున్నాను అక్కడ. మీకు డిఫరెన్స్ ఏం అంటే ఏం
natural number కంపల్సరీ కావాల్సిందని అడుగుతాను.
యా సార్, దిస్ స్టేజ్ మస్ట్ బి న్యాచురల్ నెంబర్ అంటున్నాను నేను. ఇక్కడ నేను h తీసుకున్నాను, మీరు ఏం తీసుకుంటున్నారా? ఓకే, మీ ఇష్టం తీసుకోండి. అర్థమైందా సార్? దేర్ ఎగ్జిస్ట్ స్టేజ్ n in that stage must be natural number because my terms of the sequence must be x1 x2 x3 x4 అని క్యాలిక్యులేట్ చేస్తాం కానీ x.1 x.2 x.3 అని క్యాలిక్యులేట్ చేయలేం కదా సార్. బికాస్ my function is nothing but what? Whose domain is natural numbers. My function is nothing but what? Whose domain is my sequence, whose domain is natural numbers. Therefore, the points x1, x2, x3 should be counting as a natural numbers. Right? Suppose you can take r with respect to mistam ఏదైనా సెట్ తీసుకోండి. Discrete. Right? Question is, suppose same sequence x equals to 1 by n. Does it convergent? Does it convergence? See, in this case, ఒకవేళ convergent కాకపోతే ఏమైతుందమ్మా? Otherwise, it is divergent. Xn is divergent. Yes or no? So, ఇప్పుడు చెప్పండి, discrete matrix place లో ఏమైతుందమ్మా? Does it convergent? Does the sequence convergent in discrete? Converge అయిద్దా? సపోజ్ నేను ఐ కెన్ టేక్ మై బాల్, ఎక్కడ కన్వర్జెంట్ అయితే సపోజ్ ఎక్స్ కన్వర్జెంట్ అయింది అనుకోండి, యూ కెన్ ఫైండ్ ఎక్స్ ఇన్ ఆర్ సచ్ దట్ సపోజ్ దేర్ ఎగ్జిస్ట్ ఎక్స్ ఇన్ కన్వర్జ్ ఎక్స్ అనుకోండి అని అనుకుంటే, యాక్చువల్గా నేను ఏం చేస్తానంటే, యూ టేక్ ఎ బాల్, నేను ఎక్స్ ఈక్వల్స్ టు బాల్ ఏమిస్తానంటే బాల్ సెంటెడ్ 1/2 ఇస్తాం. బాల్ సెంటెడ్ 1/2 ఇస్తాం. ఈ బాల్ సెంటెడ్ 1/2 విత్ రెస్పెక్ట్ టు డిస్క్రీట్ ఏమైంది? సింగిల్టన్ ఎక్స్. ఈ సింగిల్టన్ ఎక్స్ లో ఈ సీక్వెన్స్ టర్మ్స్ అన్ని ఉన్నాయా మరి? అండర్స్టాండ్? సీక్వెన్స్ టర్మ్స్ అంటే ఏంటి? 1, 1/2, 1/3, 1/4 going on. But my set is actually what? My set is singleton. So this neighborhood of x does not contain all terms of the sequence. There is some neighborhood does not contain all terms of the sequence. Yes or no? అర్థమైందా సార్? ఇది యాక్చువల్లీ మై నైబర్హుడ్ ఆఫ్ ఎక్స్. నేను డెఫినేషన్ ఏం చెప్పాను? What is my definition? And the definition important. Every neighborhood that you start with, it contains all terms of the sequence, except finitely many, we don't know. Is it clear? But thing in there is some neighborhood. We provide some neighborhood. We provide neighborhood. In this neighborhood, it contains only at most x. What about remaining value, countable values? Is it clear? Is it clear? Therefore, 1 by n does not converge to any x and discrete. Is it clear? Is it clear? Hello?
Okay, sir.
Okay. Suppose you can take this. Suppose constant sequence. Suppose you can take constant sequence. Any constant sequence you take. Any constant sequence always converges to x with respect to any metric. Any metric. Why? Because my constant sequence, see, give me any neighborhood. You start with any neighborhood, right? Any neighborhood around x. You take any, see, not real line. You take any neighborhood. So what is my stage is actually, you can take any stage. But what do you mean by distance between x and comma x? My sequence is constant sequence. What do you mean by distance between x and comma x? Is nothing but 0, right? Because xn is nothing but what? What is my xn? Xn is equals to x for all x. Yes or no? Therefore, xn is equals to x. That means what? This is x. Distance between x comma x. That means what? 0. 0 is always less than. So therefore, this is true for every n. Therefore, distance between xn to x is less than epsilon. Therefore, xn converges to x as n tends to infinity. So therefore, what you observe? Every constant sequence is convergent. Every constant sequence is convergent with respect to any metric. Metric to sambandham ledhiga. Any metric. Mere metric and constant sequence always convergent. Suppose my example is eventually constant sequence. What do you mean by eventually constant sequence? We say that xn is eventually constant sequence. There exists at least, if there exists at least one element in x such that after some stage, that means there exists of course m also, m belongs to n. There exists m such that after the stage, all terms are equals to x. That means after mth stage, all terms are x. So this is nothing but eventually constant sequence. Understand? Is it clear? Suppose you can take 1, 2, 3, for example, 100. After 100, 2020, 2020, 2020, right? 2020, 2020, going on. It's an eventually constant sequence. This sequence always converges to 2022. Why? Because you give me any ball around 2022, any neighbor you take around 2022. So I can take my stage is 2021. I can take my stage n equals to 2021. So after 2021, my distance between xn comma x is nothing but what? So xn is nothing but what? Xn is nothing but 2020. What is my x? 2020. So this is nothing but 0. 0 is always less than epsilon after n bigger than n. Is it clear? So therefore, distance between x to x is less than epsilon. That means what? All terms here. All terms here only. Here, the center only. So therefore, this sequence always converges to x with respect to any metric. So eventually constant sequence always converges to that constant with respect to any metric. Is it clear? So this is important. Next is in discrete metric space. This is a very, very important question. In discrete metric space, a sequence xn converges to x. In general, in discrete metric space, a sequence may not convergent. But the sequence convergent if found only, that sequence must be eventually constant sequence. The sequence must be eventually constant sequence. Understand? There exists n belongs to, there exists some h such that after h, all terms are x. Why? Already I told you eventually constant sequence is always convergent. So if it is convergent, see, suppose if you take x is in converges to x, what happens? If you take x and converges to x, what happens? So for every epsilon, there exists n in such a way that distance between x and gamma x should be less than epsilon for every n bigger than n, right? So this is true for every epsilon, but in particular, I can take epsilon equals to 1/2. So that means after the stage, distance between x and I can find the stage n in such a way that distance between x and to x is less than 1/2 after n bigger than n. So here distance possible either 0 or 1. So it cannot be 1. Therefore, distance between x and to x is 0 after n. After n. So that means distance between x and to x is 0 means what? Xn is equals to x after n. That means your sequence is eventually constant. That means your first term is same, second term is same until xn terms are same. Xn terms are keep it as it is. Remaining terms are x. Means it is eventually constant. Is it clear? So in discrete metric space, the sequence you take is convergent if and only that sequence must be eventually constant. That's what my argument. So automatically you take any discrete metric space. Suppose you take this, right? You take this. My sequence. Suppose you can take same sequence. If you take 1 by n square, you take. So automatically the sequence does not converge to any x. Why? Because my sequence 1 by 2 square, 1 by 3 square, 1 by 4 square, 1 by 5 square, it is never eventually constant sequence. It's not eventually constant sequence. So hence, it is not convergent in discrete metric space. Is it clear? Is it clear? Yes or no? Yes. Right. So next is, suppose you can take this one example. Suppose x is equals to 0, 1, continuous function with respect to D1 metric. dt. Suppose my sequence xn of t is equals to e power minus nt. So clearly continuous function because it's an exponential function is clearly a smooth function because it's infinitely differentiable in fact. Right? So therefore it is a point, it is a sequence in continuous function. So clearly each xn belongs to C01. Each point, each function is a continuous function. So what do you mean by, see, look at this function, actually look at the behavior. This tends to, it is e power minus nt, sorry, my graph is looking like this. So it is looking like xn, the function tends to 0. Therefore, your guess limit is 0. Therefore, you need to find out the distance between xn to 0 is less than epsilon. That means actually, what is this actually? At 0 to 1, modulus of fn of t minus 0 dt. That means xn of t 0. Xn of t is nothing but what? Xn of t is nothing but what? Xn of t. What is xn of t? E power minus nt dt. That means your function is actually positive function. No need to write modulus. This is nothing but e power minus nt by minus n, 0 to 1. That means actually what? This is nothing but 1 by n, 1 minus e power minus nt. That means what is this? What is this? 1 by n minus e power n into e power nt. This is true for every n. So this tends to 0 as n tends to infinity. This is non-negative. Therefore, by sandwich theorem, distance between xn to x 0 is very small. That means it tends to 0 as n tends to infinity. That means what? Xn tends to 0 with respect to D1 metric. That means xn converges to 0. Question is that, see, xn converges to 0, okay, but does it have another limit? So what is the limit of the sequence? 0. 0 is the limit of the sequence. Any neighborhood that you take around 0, it contains all terms of the sequence except finitely many. But the thing is that, does it have another limit? The answer no. The answer no, because by Hausdorff property. Every metric space is Hausdorff. Every metric space is Hausdorff space, T2 space. Why? Because what do you mean by Hausdorff? You give me any two. See, this is my metric space. You give me any two distinct points. We can separate them by two disjoint open sets. By taking the radius is very small. This is my total distance. My distance is actually what? x comma y. You give me two distinct points. Any two distinct points you take. My distance is actually what? D of x comma y. You know, it is always positive because I'm starting with two distinct points are not equal. Therefore, x and y are not equal. Therefore, r must be positive. You can take the radius is r by 2. You take the radius is r by 2, center at x. You take the radius r by 2, center at x. So you observe that these neighborhoods are disjoint. This neighborhood are disjoint. So this property is nothing but R-star property. That means you give me two distinct points, any two distinct points, I can separate them by two disjoint open sets. Separate చేయొచ్చు కదా, ఈ రెండు disjoint ఉన్నాయి కదా. You give me two distinct points, any two distinct points, I can separate them by disjoint open sets. You give me any 2 points, I can separate them by disjoint open sets. So using this property, so limit of a sequence means limit of a convergent sequence. Convergent. Problem. Yeah. So convergent sequence is unique. Limit of a sequence, convergent sequence must be unique. Why? Because suppose you assume that suppose xn converges to, suppose you assume that xn converges to x and as well as y. That means what, this is my x. Suppose you assume that xn converges to x as well as xn converges to y, both are not equal. What you observe? You can take the neighborhood as, what is my neighborhood? My neighborhood is distance between x comma y by 2. So clearly it is positive because I assume that x not equals to 1. So epsilon is positive. So that means you start with any neighborhood around x. It contains all terms of the sequence except to finitely many, because xn converges to x. As you know that xn converges to x means what? It contains all terms of the sequence except to finitely many. You know that actually xn also converges to y. So therefore, every neighborhood of x contains infinitely many points of the sequence. So if you take xn converges to y, it contains all terms of the sequence except to finitely many points. Therefore, it leaves these terms. See, ఒకటేసారి ఈ neighborhood లో infinitely many points, ఈ neighborhood లో infinitely many points ఎట్లా ఉంటాయి? xn converges to xn అంటే xn converges to x అంటే automatically this neighborhood contains infinitely many points. So therefore, this neighborhood should not contain infinitely many points. So conduction. ఈ neighborhood లో infinitely many points ఉన్నప్పుడు ఇందులో ఎట్లా ఉంటాయి? ఉండవు. So therefore, this should not converges to y. Therefore, conduction. Therefore, every limit of a sequence must be unique. Is it clear? Limit of a sequence must be unique, but this is in general need not be true. In metric space, it is true. In metric space, it is true because it's last off. It is true in only metric space. In general, this result may not be true. Yes or no? Is it clear? Suppose metric property is not inherent property. That means not a convergence property. Convergence of a sequence is not inherent. Is not inherent. Is not inherent. But may depend on the metric as well as the space. Why? Because so అంటే inherent అంటే for example మీ ఫాదర్ ఒకటి ఫర్ ఎగ్జాంపుల్ ఏదైనా ఇల్లు ఇచ్చాడు అనుకోండి, అది ఎవరికి వస్తుంది? ఆటోమేటిక్గా మీకే వస్తుంది. ఇన్హెరెన్స్ మీన్స్ వాట్? ఎక్స్ లో కన్వర్జెంట్ అయినంత మాత్రాన y లో కన్వర్జెంట్ కావాల్సిన అవసరం లేదు. సపోజ్ యూ కెన్ టేక్ x ఈజ్ ఈక్వల్స్ టు r, right? My y is equals to suppose open 0 1. My y is what? Open 0 1. So therefore, automatically, clearly, you can take this 1 by n. 1 by n, you know that we have seen that 1 by n converges to 0. 0 belongs to r in R. But 1 by n does not converge to 0 in open 0 1. Is it clear? So 1 by n converges to 0 in full space, but 1 by n does not converge to 0 in subspace. So that means what? Convergence property is not inherent. Convergence of a sequence is not inherent. Is it clear? ఒక sequence full space లో convergent అయిన మాత్రాన that doesn't mean that is convergent in a subspace. Is it clear? Is it clear?
Yes.
Hello, are you
Okay,
there?
sir. Okay, sir.
Okay, sir.
Suppose సీక్వెన్స్ ఇక్కడ ప్రాబ్లం ఏంటి యాక్చువల్గా అంటే So the thing is, but ఇదే sequence ఇట్లా ఉందనుకో అయిద్ది మరి. Understand? Suppose you take the sequence, అంటే యాక్చువల్గా పాయింట్ అనేది ఇక్కడ ఏంటంటే పాయింట్ ఈ సెట్లో లేదు కాబట్టి కన్వర్జెంట్ అయితే లేదు కదా. నేను ఏమని చెప్పాను డెఫినేషన్, కన్వర్జెంట్ కావాలంటే దేర్ ఎగ్జిస్ట్ ఏ పాయింట్ ఇన్ ఏ మెట్రిక్ స్పేస్ కదా. ఇదే డెఫినేషన్ అది. దేర్ ఎగ్జిస్ట్ ఏ పాయింట్ ఇన్ ఏ మెట్రిక్ స్పేస్ సచ్ ద డిస్టెన్స్ బిట్వీన్ x to x is less than epsilon అని చెప్పాను. ఫస్ట్ పాయింట్ అనేది సెట్లో ఉండాలి. ఇక్కడ థింగ్ ఏంటంటే ఆ పాయింట్ సెట్లో లేదు, 0 అనేది సెట్లో లేదు. ఎస్ నో, is it clear? Therefore, actually, suppose you can take y is a subset of a metric space. Suppose yn is my sequence in y. So yn converges to y in y means yn converges to y in x. When do you say this? Whenever y belongs to x. ఇక్కడ దీని డిఫరెన్స్ ఏంటమ్మా, ఈ y అనేది ఇందులో ఉంది. yn converges to y అంటే ఏంటి, y ఇందులో ఉంది. Is it clear? So yn converges to y means in y means, what is my definition? There exists a stage such that all terms should be in the ball centered y comma epsilon for every n bigger than n. This is my definition. After the stage, all terms should be in the ball. That means xn belongs to the ball centered. What do you mean by ball centered y comma epsilon? This means it is in the ball centered y comma epsilon in x intersection with y, right? That means x is in the intersection means what? X should be in the ball centered, sorry, yn. So yn should be in the ball centered y comma epsilon. This is true for n bigger than n. That means after nth stage, all terms in the ball centered y comma epsilon. That means what I mean this, yn converges to y in x matrix, because my ball is this in a full space. Therefore yn converges to y if and only if yn converges to x. So using this relation, one can easily compute that if a sequence, suppose you can take this sequence, y is subset of x, yn is a sequence in y, right? Suppose yn converges to, suppose you can take y which is in x but not in y, that will imply that yn does not converge to any point, converge to any point of y. Is it clear? yn converges to y, yn అనేది కన్వర్జెన్స్ x లో అవుతుంది, బట్ ఈ పాయింట్ x y లో లేదమ్మా. ఈ పాయింట్ ఏంటి, y లో లేదు. yn కన్వర్జెంటే ఎక్కడ, x లో కన్వర్జెంట్ అవుతుంది. ఈ బట్ అయినంత మాత్రాన y అనేది y కి కన్వర్జెంట్ కాదు, అసలే కాదు. ఎందుకు? ఒకవేళ కన్వర్జెంట్ అయింది అనుకున్నారు అనుకోండి, సపోజ్ యు అస్యూమ్ దట్ ఇట్ ఈస్ కన్వర్జెంట్ ఇన్ y for some x in y, right? By previous result yn converges to x in x, because x ఎక్కడ ఉంది, y లో ఉంది కాబట్టి by previous result yn converges to x in x. Yes or no? But ఇంతకుముందు చెప్పాను limit of a convergent sequence must be unique అని. Therefore as you know that yn converges to y and yn converges to x, therefore x is equals to y. Yes or no? X is equals to y. That means y equals to x. That means x ఎక్కడ ఉంది, యాక్చువల్ గా x ఎక్కడ ఉంది, y లో ఉంది, రైట్? Therefore y ఎక్కడ ఉంటుందమ్మా, x లో, y లో ఉంటుంది. Which is absolutely contradiction, because y ఎక్కడ ఉంది, యాక్చువల్ గా y లో లేదు. సో therefore ఏదైనా సీక్వెన్స్, దీని మీనింగ్ ఏంటంటే ఏదైనా సీక్వెన్స్ ఒకదానికి కన్వర్జెంట్ అయింది అనుకోండి, ఆ పాయింట్ ఇక్కడ ఇంతకుముందు అదే చెప్పాను, ఓపెన్ 0 తీసుకున్నారు, 1/n తీసుకున్నారు, 1/n అనేది 0కి కన్వర్జెంట్ అయింది, బట్ 0 అనేది సెట్ లో లేదు కాబట్టి 1/n నెవర్ కన్వర్జెస్ టు ఎనీ పాయింట్ ఇన్ ఓపెన్ 01 బై యూజింగ్ దిస్ రిజల్ట్. అండర్స్టాండ్? 1/n వేరే దానికి కన్వర్జెంట్ అవుతుందా సార్? నో, వేరే దానికి కన్వర్జెంట్ కాదు. 0కి కన్వర్జెంట్ అయిన తర్వాత ఇక వేరే దానికి కాదుగా. ఇది క్లియర్? బై యూజింగ్ దిస్ డెఫినేషన్, యూజింగ్ దిస్ ప్రాపర్టీ. సో 1/n ఒక దానికి 0 కన్వర్జెంట్ అయినప్పుడు 0 డస్ నాట్ బిలాంగ్స్ టు ద సెట్. Therefore by using this property 1/n does not converge to any point. ఒక్కసారి ఒక దానికి కన్వర్జెంట్ అయింది అనుకోండి, గుర్తుపెట్టుకోండి, మెట్రిక్ స్పేస్ లో మళ్ళీ వేరే దానికి కన్వర్జెంట్ కాదు ఇక, బికాస్ హాస్టల్ ప్రాపర్టీ, T2 ప్రాపర్టీ. అండర్స్టాండ్? సో లిమిట్ ఆఫ్ ద సీక్వెన్స్ మస్ట్ బి యూనిక్ కాబట్టి రెండో దానికి కన్వర్జెంట్ అయ్యే ఛాన్స్ లేదు. 1/n కన్వర్జ్ టు 0 అయినప్పుడు ఇక 0కే కన్వర్జెంట్ అవుతుంది. సో అది స్పేస్ లో కన్వర్జెంట్ అయితే కాదనేది క్వశ్చన్. 1/n does not converge to x for any x which is in open 01. Is it clear?
Okay,
Is it clear?
okay, sir.
Right? right? Suppose you can take this. Suppose you can take x is equals to r. My metric is actually what? Suppose my metric is del of x comma y is equals to mod of x minus y by 1 plus mod of x minus y. Right? So 1 by n తీసుకున్నారు. Question is, does it converges? Does it converges to x for some x belongs to r in with respect to delta metric? Is it clear? ఈ మెట్రిక్ స్పేస్ లో ఇది కన్వర్జెంట్ అయిద్దా? క్వశ్చన్ 1 by n అనేది x కన్వర్జెంట్ అయిద్దా? 1 by n అనేది x కన్వర్జెంట్ అయిద్దా? Can you say that 1 by n convergent in with respect to delta metric? The answer is yes. Because using this property, so this is very, very important property. Suppose x is a metric space, d1, d2 are two metrics on x. In fact, they are equivalent metric. What is that? d1, d2 are equivalent metric. So xn converges to x in d1 metric if and only if xn converges to x in d2 metric. Using the definition only. Using equivalent matrix definition. One can easily derive it. So xn converges to x if and only. See, చూడడానికి something ఏదో typical లా కనిపిస్తుంది కదా, బట్ మీకు తెలుసు ఇది this you know that x with respect this ఇది ఎట్లుందమ్మా, ఇది యూజువల్ మెట్రిక్ కదా, ఇది ఎట్లుంది చెప్పండి. So therefore this is delta of x comma y is equals to d of x comma y divided by 1 plus d of x comma y, where d of x comma y is mod of x comma y. Right? We have seen that delta and d are equivalent on x. Therefore, as you know that 1 by n converges to 0 in d, in x comma d, means in r with respect to d. So therefore, by using this property, 1 by n converges to 0 in r with respect to delta. Is it clear? Is it clear? Very, very important. చూడండి ఎంత నైస్ ప్రాపర్టీ ఇది. యాక్చువల్గా చూడండి ఈ ప్రాబ్లం ఎట్లో సంథింగ్ డిఫికల్ట్ గా కనిపిస్తుంది, కానీ మనకు ఒక టెక్నిక్ తెలుసు. ఈక్వలెంట్ మెట్రిక్స్ అయితే ఓపెన్ బాల్స్ సేమ్ అని, ఓపెన్ బాల్స్ కంటైన్స్ అనదర్ అని, ఈచ్ ఓపెన్ సెట్ కలెక్షన్ ఆఫ్ ఓపెన్ సెట్ ఈ సేమ్ సేయింగ్ దట్ కలెక్షన్ ఆఫ్ ఓపెన్ సెట్ విత్ రెస్పెక్ట్ టు d2 అని. సో ఓపెన్ సెట్ సేమ్ అని అంటే కన్వర్జెన్స్ సేమ్ అవుతుంది, బికాజ్ ఇట్స్ టోపాలజికల్ ప్రాపర్టీ. So xn converges to x in one metric space automatically if and only if xn converges to x with respect to another metric. Right?
Yes,
Suppose you can take this. Suppose x with respect to x is equals to r with respect to del of x comma y is equals to, you can check it, you can solve it, mod of x minus y. Suppose my sequence is 1 by n square. Does it convergent? First, does it convergent? The answer yes, because already I told you delta of x comma y is equals to minimum of 1 comma d of x comma y, where what is my d of x comma y? Usual metric. We have seen that delta and d are equivalent metric yesterday class. Equivalent and x equals to r. Therefore, we have seen that 1 by n square tends to 0 in usual metric space. నా పెన్ను కొంచెం ప్రాబ్లం ఉంది, అది రిఫిల్ చేంజ్ చేయాలనుకుంటాను. సో 1 by n square రాయట్లేదు. 1 by n square tends to 0 r in with respect to usual metric. So by previous property 1 by n tends to 0 in r with respect to delta. Is it clear, sir? Is it clear?
okay,
Right? Suppose you can take this one. Suppose you can take x is equals to r, x is equals to natural numbers. Suppose my d of x comma y is 1 by x minus 1 by y. Suppose my question is 1 by n. Does it convergent? Does it convergent? Anybody? Does it convergent? The answer no, because already told you d x comma d whenever x is a natural numbers is nothing but discrete metric space. We have seen yesterday. It's a discrete metric space. In discrete metric space, when do you say that sequence convergent? It is eventually constant. It is eventually constant. Is it eventually constant? So therefore the sequence never convergent in natural numbers with respect to d. Is it clear?
okay,
Is it clear? Hello?
okay, sir. Sir, let us close.
Yeah,
Within 2
time
minutes.
అయిందా సార్? టైం అయిందా సార్?
అందరు మర్చిపోయిన టైం ని.
అయ్యో.
No problem.